Yes, there are indeed strain reliefs designed for installation on flexible metal conduit, or flex, that is already in place and wired. These are commonly known as split strain reliefs or saddle strain reliefs. Their primary function is to provide mechanical support and prevent stress on the electrical connections within the conduit, ensuring long-term reliability and safety. These strain reliefs are typically constructed from either plastic or metal, offering durability and resistance to various environmental factors. They are engineered with a two-piece design, featuring two halves that can be easily snapped together around the existing conduit. This eliminates the need to disconnect or disturb the wiring during installation. The design incorporates holes or slots strategically placed for the insertion of screws or bolts, allowing the strain relief to be securely fastened to a mounting surface such as an electrical box or equipment enclosure. This secure attachment is crucial for effectively transferring any pulling or twisting forces away from the delicate wire terminations inside the conduit. To acquire split strain reliefs, you have several options. Firstly, home improvement stores are a convenient starting point. They usually stock a range of electrical supplies, including various types of strain reliefs. Secondly, electrical supply stores are another valuable resource. These specialized stores cater specifically to electricians and electrical contractors, offering a wide selection of strain reliefs and other electrical components from various manufacturers. Their knowledgeable staff can also provide expert advice on selecting the appropriate strain relief for your specific application. Thirdly, online retailers offer a vast marketplace for electrical supplies. Websites like Amazon and Gringa carry an extensive inventory of split strain reliefs from numerous brands, often at competitive prices. Online retailers also provide detailed product descriptions and customer reviews, which can aid in your decision-making process. Now, let's delve into the step-by-step installation process for split strain relief. Safety should always be the top priority when working with electricity. The very first step is to turn off the power to the electrical circuit that the conduit is connected to. Locate the circuit breaker or fuse that supplies power to the circuit and switch it to the off position. To ensure that the circuit is indeed energized, use a non-contact voltage tester to verify that there is no voltage present on the wires within the conduit or the connected equipment. Next, carefully examine the split strain relief. You will notice screws or bolts that hold the two halves together. Loosen these fasteners, but do not remove them completely. The goal is to create enough space between the two halves so that they can be easily placed around the conduit. Identify the section of the conduit where you want to install the strain relief. Ideally, this should be near the point where the conduit enters an electrical box, junction box, or other enclosure. This proximity will maximize the strain relief's effectiveness in preventing stress on the wire connections inside. Take one half of the split strain relief and position it around the conduit at the chosen location. Ensure that the conduit is properly seated within the contours of the strain relief half. Carefully bring the other half of the split strain relief around the conduit, aligning it with the first half. The two halves should snap together securely, forming a complete enclosure around the conduit. You may need to apply gentle pressure to ensure a tight fit. Once the two halves are snapped together, carefully tighten the screws or bolts that hold them in place. Use a screwdriver or a wrench of the appropriate size to tighten the fasteners securely, but avoid over-tightening, which could damage the strain relief of the conduit. The strain relief should be firmly attached to the conduit, providing a secure grip and preventing any movement. After the strain relief is securely installed, perform a visual inspection to ensure that all connections are properly tightened and that there are no loose wires or exposed conductors. Double-check that the strain relief is firmly mounted to the conduit and that it is providing adequate support. With the installation complete and all safety checks performed, you can now restore power to the circuit. Locate the circuit breaker or fuse that you switched off earlier and switch it back to the on position. After restoring power, test the circuit to ensure that it is functioning correctly. Use a multimeter or other appropriate testing device to verify that the voltage and current levels are within the expected ranges. Check any connected equipment to confirm that it is operating normally. Following these steps will allow you to install a split strain relief effectively. Electrical work can be dangerous, so if you are not comfortable performing these tasks yourself, it is always best to consult a qualified electrician. They have the expertise and experience to handle electrical installations safely and ensure that all work complies with local electrical codes. Split strain reliefs are invaluable components for enhancing the safety and reliability of electrical systems using flexible metal conduit. Their ease of installation and robust design make them an essential addition to any electrical project. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including the proper use of strain reliefs. Adhering to these guidelines is crucial for ensuring the safety and compliance of electrical systems. The NEC mandates the use of strain reliefs in various situations, such as where flexible metal conduit is used to connect equipment that is subject to movement or vibration. This requirement is intended to prevent stress on the wire connections and reduce the risk of electrical hazards. In addition to the NEC, local electrical codes may also have specific requirements for the installation of strain reliefs. It is important to consult with your local building department or electrical inspector to ensure that your installation complies with all applicable regulations. Regular inspection and maintenance of strain reliefs are essential for ensuring their continued effectiveness. Over time, strain reliefs can become loose or damaged due to environmental factors or mechanical stress. Periodically inspect the strain reliefs in your electrical system to identify any signs of wear or tear. If you notice any problems such as loose fasteners, cracks, or corrosion, replace the strain relief immediately. Remember, electrical safety is paramount, and properly installed and maintained strain reliefs play a critical role in protecting your electrical system and preventing potential hazards. When selecting a split strain relief, it's crucial to ensure it is appropriately sized for the conduit you are using. Flex conduit comes in various diameters, typically measured in inches. Using a strain relief that is too small will not properly grip the conduit, while one that is too large will not provide adequate support. Consult the manufacturer's specifications or a sizing chart to determine the correct strain relief size for your conduit. You may also encounter different types of split strain reliefs designed for specific applications. For instance, some strain reliefs are specifically designed for use in wet locations or corrosive environments. These strain reliefs are typically made from corrosion-resistant materials and have a watertight seal to protect the electrical connections from moisture and contaminants. Other strain reliefs may be designed for use with specific types of conduit fittings, such as connectors or couplings. These strain reliefs may have specialized features that allow them to be easily integrated with the fittings. In addition to split strain reliefs, there are also other types of strain reliefs available, such as cord grips and cable glands. Cord grips are typically used to secure electrical cords or cables to equipment, while cable glands are used to seal and protect cables as they enter an enclosure. The choice of strain relief will depend on the specific application and the type of wiring being used. When installing a split strain relief, pay close attention to the orientation of the strain relief. Some strain reliefs have a specific orientation that must be followed to ensure proper performance. The manufacturer's instructions will typically indicate the correct orientation. Ensure that the strain relief is oriented correctly before tightening the fasteners. It is also important to avoid over-tightening the fasteners on the strain relief. Over-tightening can damage the strain relief or the conduit, potentially compromising its effectiveness. Use a torque wrench to tighten the fasteners to the manufacturer's specified torque value. If a torque wrench is not available, tighten the fasteners snugly, but avoid applying excessive force. When working with electrical systems, it is always advisable to wear appropriate personal protective equipment, or PPE. This may include safety glasses, gloves, and insulated footwear. Safety glasses will protect your eyes from debris, while gloves will protect your hands from electrical shock. Insulated footwear will provide an additional layer of protection against electrical hazards. Before starting any electrical work, always take the time to inspect your tools and equipment. Ensure that your tools are in good working condition and that they are properly insulated. Replace any tools that are damaged or worn. It is also important to keep your work area clean and organized. Remove any clutter that could create a tripping hazard or interfere with your work. A clean and organized work area will help you to work more efficiently and safely. If you are working in a confined space, ensure that there is adequate ventilation. Electrical equipment can produce heat which can cause the air in a confined space to become hot and stagnant. Adequate ventilation will help to keep the air cool and fresh. If you are working in a damp or wet environment, take extra precautions to protect yourself from electrical shock. Wear waterproof gloves and footwear, and avoid touching any metal objects that could be grounded. If possible, turn off the power to the circuit before working in a damp or wet environment. When working with electricity, it is always better to be safe than sorry. If you are unsure about any aspect of the work, consult a qualified electrician. An electrician can provide expert advice and assistance, ensuring that the work is performed safely and correctly. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety guidelines, you can minimize the risk of electrical hazards and ensure a safe working environment. Consider also the long-term effects. The choice of materials and a strain relief should be compatible with the environment where it will be installed. For example, in coastal areas where salt air is prevalent, stainless steel or marine-grade aluminum strain reliefs are preferable to prevent corrosion. In industrial settings where exposure to chemicals is likely, chemical-resistant plastics or coated metal should be used. Also consider the temperature range the strain relief will be exposed to. Some materials become brittle or deform at extreme temperatures, which could compromise their functionality. The expected lifespan of the installation should also influence the choice of strain relief. For temporary installations, less durable materials may suffice, but for permanent installations, investing in high-quality, long-lasting strain reliefs is a wise decision. When multiple conductors are run through a single conduit, ensure that the strain relief is adequately sized to accommodate all of them without causing undue pressure or stress on the individual wires. Some strain reliefs are specifically designed for multi-conductor applications. Always refer to the manufacturer specifications for guidance. The installation of a strain relief can also impact the overall aesthetics of the electrical installation. Consider the color and finish of the strain relief and choose one that blends in with the surrounding environment. In some cases, paintable strain reliefs are available, allowing you to customize the color to match the existing decor. Furthermore, the placement of the strain relief should be carefully considered to minimize its visual impact. Position it in a location where it is least likely to be noticed, while still providing adequate support and protection. The selection of a strain relief should also take into account any applicable industry standards or certifications. Look for strain reliefs that are UL listed, CSA certified, or meet other relevant standards. These certifications indicate that the strain relief has been tested and meets certain performance and safety requirements. Using certified strain reliefs can provide added assurance of their quality and reliability. When selecting a strain relief, it is also important to consider the ease of installation and maintenance. Choose a strain relief that is easy to install and requires minimal tools. This will save time and effort during the installation process. Also consider the ease of maintenance. Select a strain relief that is easy to inspect and clean. This will help to ensure its long-term performance and reliability. Remember, the selection of a strain relief is an important decision that should be based on careful consideration of all relevant factors. By taking the time to choose the right strain relief, you can ensure the safety, reliability, and longevity of your electrical installation. When documenting your electrical work, be sure to include details about the strain reliefs used. This information can be valuable for future maintenance and repairs. Record the type, size, and manufacturer of the strain reliefs used, as well as their location and date of installation. Keep this information in a safe and accessible place, such as an electrical panel schedule or a project file. Also, consider taking photographs of the installation, including close-ups of the strain reliefs. These photographs can be helpful for identifying the strain reliefs in the future and for verifying their proper installation. When performing electrical work, it is always a good idea to have a second person present. This person can provide assistance, monitor your progress, and call for help in case of an emergency. Inform the person about the electrical work you will be performing and the potential hazards involved. Ensure that the person knows how to shut off the power to the circuit in case of an emergency. Also, keep a first aid kit readily available in case of any injuries. Electrical shock can cause serious injuries, so it is important to be prepared for any eventuality. By taking these precautions, you can minimize the risk of accidents and ensure a safe working environment. Remember, safety is paramount when working with electricity. Always take the time to plan your work carefully and follow all safety guidelines. If you are unsure about any aspect of the work, consult a qualified electrician.